Hey guys, in the last video we talked about a population versus a sample. So pause this in a second and see if you remember what a population is compared to a sample. Okay, well this is the image I drew in the last video. You'll remember the population is the larger group. So here all U.S. college students would be a population. And then we talked about that ONU students could be a sample, or they could actually be a population at the same time. So, and then a smaller group within would be a sample. A key idea, though, is that a sample should be what we call representative of population. And maybe you can think of your U.S. representative in Congress, okay? They're supposed to represent you. They're supposed to really match your beliefs and your opinions, and they are there to represent you as a constituent. Now, when we say a sample should be representative of the population, we want it to match. And so how do we do that? Like if we were interested, sometimes we just think about it logically. If, say, we worked for an alcohol company, we wanted to know something about college student alcohol use. Would ONU students be a good representative sample of the U.S. college students? I would hope not, right? Hopefully our alcohol use is lower than U.S. college students, so that probably wouldn't be the best way to create a sample. How do we create a representative sample? Well, in the next page here, this is from class activity 15B. Here's some ideas, and I want you to just read through them and say, what do you think? Yes, representative, or no, not representative. And so pause it now and just go through A through E. How about asking your friends? I would say no. Likely they're your friends because they have similar perspectives, similar tastes, similar opinions as you. Even if you feel like you're pretty diverse and you have a wide range of friends, it's just unlikely that you're going to get a pretty representative perspective of, say, the campus. Ask as many of your classmates as you can. Well, again, I would say probably not. Though, maybe, depending on the question, depending on the class. But, say, well, I would ask in one of my gen ed classes. Well, I'm going to guess your gen ed classes are heavy on undergraduates, so likely you're going to get a different perspective than if you sample from everyone. Stand outside the buildings the classes are in. Again, I'm going to say no, and again, maybe, it depends. But again, likely if we stand outside of a building, it depends on the classes, right? If you stand outside of Weber, you might get different types of people than if you stand outside of Larson. And even that, the time of day might have an impact, right? If you stand outside of Ludwig at 7 in the morning compared to 10 in the evening, you might get a different type of person that might affect how representative they are of the sample. Now, I guess that kind of is D. Student union or common meeting area. Try to pick people who you think are representative. Maybe, but again, I would say probably not. And the reason is similar to what I've said. There might be people that seem more approachable, people who you kind of build in your own stereotypes if you try to pick people yourself. Now, you might count people coming in the door and every 10th person ask them, regardless of if they're scary looking or a friend or not. And that might be a better chance of being representative. But you still have the time of day issue. And the last one here, generate a list of random numbers between 1 and the number of students at the college. Pick names out of the student phone book corresponding by the random numbers and contact that person. This is probably going to be more representative because everyone in the college has an equally likely chance of being chosen. Equally likely chance of being chosen. And that's a key idea. If we have a truly random sample where everyone has an equally likely chance of being chosen, you are going to tend to be more representative. Now, you might say, well, okay, let's say I'm interested in Discover Card. Couldn't I randomly choose, say, 30 people that all happen to have a credit card? Like, maybe there's still a lot of people that don't. And you're right, that is possible. That's part of variation and statistics, is we have to deal with this chance that we might have randomly chosen 30 people who had credit cards. But here's the deal. Say you have a campus of 3,000 students. If only 30 of them have a credit card, it's super unlikely that you would actually choose just those 30 if you were doing a truly random sample. Likely, the random sample that you have would match or represent the population. So, I don't know if this will help or not, but let's say I have a pie chart. And let's say this is the population, and let's say that this shaded section here is 30%. Well, if you randomly select a sample, that's not really what I wanted to do. There we go. Let's say you randomly selected a sample. I'm wanting it to move and not get bigger. All right, we'll try it this way. I know this will work. Maybe not. There we go. That's what I wanted to do. Do you see that this, if this was my sample, that likely 30% of my sample will also have a credit card or whatever the characteristic is that I'm interested in? And that's the whole idea of samples, populations, and statistics. And I apologize for my sloppy handwriting. I'll try to slow down in the future. So, I asked you to enter a random number in a Google form between 1 and 10. 30 of you responded, and this is what we found. 2 people picked 3, 4 people picked 7, 5 people picked No, I said that wrong. This is the number chosen down here, and this is the frequency, or how often. So 2 of you chose 3. 7 of you chose the number 4. 3 of you chose the number 5. 4 of you chose the number 6. 5 of you chose the number 7. 8 of you chose the number 8. And 1 of you chose the number 9. Now, you see some variation here, and that's okay. But I would suspect there's some patterns. You'll notice nobody chose the numbers 1 or 2. Nobody chose the number 10. A lot of people chose 8, which is interesting. Now, with only 30, we may not be able to say too much, but if we would have asked 300 people, if it's truly random, we would expect these to be more evened out, if everybody had an equally likely chance. We don't realize our biases, okay? We don't realize our biases. It seems like the number 8 had a bias. The number 4 had a bias. Now, maybe not. What I've done is I actually did this using Excel, and this is truly random. And you'll notice these aren't all the same height either. Excel even though it was truly random, chose the number 3. Sorry, that's frequency. Chose the number 3 7 times. That's quite a few. 2, 7, and 10 were pretty high, and then you have numbers like 1, 5, and 8 that were pretty low. Now, notice though, none of them were chosen 0 times. Also, this is with only 30. I would expect over time that these would even out because it's truly randomly it's randomly choosing them. Where a class survey, if we have unknown biases that help us get to 4 and 8, these would probably keep growing compared to 1 and 2 and 10. And so I just want to point this out, that getting something that's truly random is challenging, and really the best way to do that is by using random numbers to get a random sample that will more likely match the population than if we just happen to choose them in one of these other ways. Now, getting a truly random sample in real life is challenging. It requires a list of everyone. So you can imagine, like, at election time, how do you get a list of everyone in the state or everyone in the country? That's really hard to do. So they have to rely on other sampling techniques, which we aren't going to get in this class. The main takeaway is that we're going to choose random samples. Thanks for your